So this lecture is going to be continuation of the previous one. If you have any doubt, I can clarify it. Okay, exactly. This is what we have discussed in the previous class. So we derived the equation, Henderson equation, which is pH is equal to pKa plus log base form by acid form. And we discussed about what is acid form, what is meant by protonated state, what is meant by unionized state, what is base, what is called as unprotonated state, what is called as ionized state. So then we took one drug molecule as example, amobarbital. So which is in its acid form. Okay, if you put this molecule in some basic environment, so the molecule will be in a deprotonated state, that is the conjugate base of that acid. So we solve a numerical problem at pH 7.4. What's the percentage of ionization of amobarbital, whose pK value is 8.0? And finally, we got the answer as 79.9 percentage of the molecule will be in its ionized state. Am I right? That is what we
So
have discussed,
in
right?
yes, sir.
Huh?
In
So any doubt in
unionized
this,
state,
I can answer.
in
In
unionized form, 79%. Sir.
so percentage of ionization in unionized form 79.9 percentage. 79.9 percentage will be in unionized form. Yeah, right. You are right. Okay. So any doubt in this?
No, sir.
You okay? I stop sharing. Okay, so we are going to solve some few more problems in this class. Just note in the second problem. One- Just a few seconds. Okay. So is my screen visible now?
No, sir.
Now? Is it visible?
No, sir. It's visible, sir.
Yeah, so we will go for this problem, right? So note on the problem. Everyone please note it down on the notebook. Okay, we are going to solve set of problems, right? So continuation of the previous one, the pK of aspirin, a weak acid is 3.5. Calculate the degree of ionization of aspirin in stomach and intestine. If the pH of the content of the stomach is 1 and the pH of the content of intestine is 6. Okay, so everyone you solve in your notebook. First thing what you have to do is you have to draw the structure of aspirin. Okay, again I repeat, the first step of solving this problem is you have to draw the structure of aspirin in the notebook. And it is given aspirin is a weak acid. Okay, the pK is 3.5. And you have to try to encircle which functional group in the aspirin is responsible for its acid nature, and for which functional group the pK value is corresponding for 3.5. Because in one of the lecture we already discussed about the various functional groups and the corresponding pK value. Okay, so you have to encircle which functional group of aspirin has the pK value approximately equal to 3.5. Okay, that's the second step. The third step is they have given two pH. One is pH at stomach and the another one is pH at intestine. The pH at stomach is given as 1 and the pH at intestine is given as 6. So this also we already discussed various fluids in the body, what's the corresponding pH. So here straight away they have given the pH for stomach and intestine. So for two cases, right? So for if the pH is 1, what will be the percentage of ionization, degree of ionization? If the pH is 6, what will be the degree of ionization? So you have to solve this problem. Is it understandable?
Yes, sir.
Can you solve? I can give maximum of 10 minutes for this. So time is 9:05. Okay, so everyone please complete before 9:15. I'll show how to solve. Okay, so you just give a try. What I need is the final answer. Degree of ionization in stomach and degree of ionization in intestine for the aspirin. That's all. So once if you completed, just let me know in the chat box. All right. So I'll show you how to solve. Is the question visible?
Yes, sir.
Yeah, anybody solved? 10 minutes over. I think more than enough for this problem. Anybody got answer? Hmm? See, again and again, I am saying that I need some kind of response. I don't know whether I connected or you connected. So I'm getting some reply in the chat box. Yes, sir. Okay. So can you tell the answer at stomach? pH is 1, right? So what's the degree of ionization of aspirin in what is the degree of ionization at stomach?
Sir, is it 0.3162 percentage, sir?
What's the degree of ionization in stomach? Okay, I'll come back to wait. So what is the degree of ionization? Degree of ionization. I hope you know the difference. It's a question. So I need to answer now. Yes, Shashank, you can tell. So what's the value you got for unionized by ionized for pH at stomach? What's the value you got? Sure. So the formula is pH is equal to pK plus log base form over acid form. You can rewrite this equation in different ways, right? So what I need is what's the degree of ionization of aspirin in stomach, or you can tell what's the value you got for unionized over ionized.
316.22.
So the value for this is 316.22.
22, sir.
Who said 22? Okay, fine. So what the value you got for the second case in intestine? Unionized by ionized. What the value?
3.16 into 10 to the power minus 3.
Unionized by ionized
Sir, I guess
is
yes, sir. 3.16 to the power
3
minus
point.
3 is for
Yeah. 316.23. Whatever value you said. Can we write it as 1 by 316.22 or 23?
Yes, sir.
Shashank.
yes, sir.
Okay, so what is our understanding from the first one? So can we say that for every 316.22 molecule, there will be one molecule in its ionized form? Again, I repeat, for every 316.22 molecule in its unionized form, there is going to be one molecule in its ionized form. Am I right?
Yes, sir.
Yes, right. So for the second case, for every one unionized molecule, there are going to be 316 molecule in its ionized form. Am I right?
Yes, sir.
So at what pH the degree of ionization is more? In stomach or intestine? In stomach or intestine, more number of molecules will be in its ionized form. Is it a difficult question? Either it could be a difficult question, or only one or two students join. Others, I don't know. I'm not getting response from it shows that there are 31 students join. I'm not getting any response. Is my screen visible?
Yes, sir.
Okay, so what's the problem?
Sir, it is ionized in intestines, sir.
More number of molecules will be ionized in intestine. Do you agree?
Yes, sir.
Yes, right? Okay, fine. So what I'm going to do is I'm going to draw the structure of aspirin now. So I hope you people already installed Marvin Sketch, right?
Yes, sir.
Okay, so whenever I say the name of any drug molecule, if I ask you to draw the structure, so don't go for Google search, right? So just use the software. It will generate the structure. You can get very clear structure out of this Marvin Sketch. So what I'm going to do is I'm going to draw the structure of aspirin. I think already I have the structure of aspirin. Just I insert it. Picture. Yeah, desktop. Okay, yes. Okay, aspirin. Yeah. So go to structure, name to structure, and aspirin. Right. So I got the structure of aspirin. So this is the structure of aspirin. File save as. Desktop. Image. Desktop. Aspirin. Insert picture. Aspirin. So is the structure visible now?
Yes, sir.
Okay, so they mentioned that aspirin is a weak acid, right? So which means that it is acid. Okay, so but it cannot dissociate completely. So can you tell which functional group is corresponding for this the pKa 3.5? So in one of the lecture we discussed about the various functional groups and their corresponding pKa value. If you remember, do you remember?
Yes, sir.
Yes, right. So based on that lecture class, can you refer the lecture note and tell me which functional group in this aspirant is corresponding for the pK value 3.5? The question is very simple, straightforward. So we discussed about the pK value for various functional group. For which functional group the pK value is closer to 3.5, approximately, not exactly.
Carboxylic acid.
Carboxylic acid, absolutely right. So I think that I can get an answer only from 2 students, not from others, right? Okay, that's fine. So can you tell which group is the carboxylic acid group? This one, right?
Yes, sir.
Am I right? Okay,
Yes, sir.
so what will happen if we put this molecule aspirin? Okay, say for example water. In a water, what will happen? There is going to be a structural change, right? So what exactly happens is, so the molecule, okay, so I just draw the structure, right? So the ionization is going to take place. So the structural change that will affect in this molecule is, so you will be having O here, uh, double bond O here, and SEH3 here. No, there won't be any change in this position. But in this position, you have COOH, C double bond O, right? So this hydrogen will be cleaved. So you'll get O minus and H plus. So now can we call this now aspirin is in its ionized form?
Yes, sir.
Yes, right. So the molecule is in its ionized form. So when this will happen, that depends on the pH of the solution. So it can easily donate its proton if the pH is at what pH it can easily donate its proton. So here we have two pH, 1 and 6.
1, sir.
Again I repeat, at what this molecule is in its ionized form. My question is at what pH more number of this molecule will be in its ionized state? At pH 1 or 6? That's a calculation what we have made here. This question is not general question.
6, sir.
Huh?
6
At,
pH
at,
6.
at the pH 6. Are you able to understand? So at the pH 6, for every one molecule in its ionized form, 316 molecule will be in its ionized form. Again, I repeat, for every one molecule in its unionized form, there is going to be 316 molecules in its ionized form. But at pH 1, for every 316 molecule in its unionized form, only one molecule will be in its ionized form. So at pH, we can say more number of molecules, aspirin will be in its ionized form. Do you agree?
Yes, sir.
So I am not happy with your class. Everyone, what you're going to do is so everyone is going to unmute and you have to tell your name now. Aishwarya.
Yes, sir.
Yeah, Nisha.
Yes, sir.
So you're not interested to participate in any discussion, right?
Not like that, sir.
Then what? That is what I can understand. I am getting answer either from Aishwarya or Shashank. I don't know whether I teach for the entire class or only for 2 students. I never received any answer from you so far, right? So many classes over. Anybody with the name Harini?
Yes, sir.
Is anything restrict you to answer? I also did not receive any answer from you so far. Is there any problem for you to participate in the discussion?
No, sir.
Then what's the problem? So you people allotted Aishwarya and Shashank only to answer for all the questions, right? The others cannot open mouth.
No, sir. Sorry, sir.
Then what's the point of, we are not, this is not face-to-face teaching, right? So I don't know how many join. At least if you participate, I can understand, okay, a few number of students joined and they are, learning something. If I get answer only from Aishwarya and Shashank, I can teach only for them.
So we will be more interactive, sir.
Okay, so is it understandable? So at pH 6, more number of aspirin molecule will be in its ionized form. Is that statement? Do you agree with that statement from this problem?
Yes, sir.
Yes,
Yes,
sir.
right? Okay. Okay.
Yes, sir.
So, okay, I am going to now tell one important point, right? So why we do all this calculation, right? So there should be some meaning for doing all this calculation. So already we know that, the cell is made up of cell membrane. Okay, so inside the cell we have, some important organelles. Say this is the nucleus, and so there are many organelles there, right? So the most important feature of the cell is cell membrane. Okay, so the nature of the cell membrane is it is made up of kind of a lipid bilayer, phospholipid bilayer. Okay, so if you take any drug molecule, so if the drug molecule has to enter into the cell, say I'm saying this as the drug molecule. So if this drug molecule has to enter into the cell, so what the first thing should happen is that the molecule should able to cross this barrier. Do you agree? So then only the molecule can enter into the cell. Am I right? So this is outside the cell and this is inside the cell. So if the molecule has to produce the desired biological response, first thing is the molecule should enter into the cell. For entering into the cell, the biggest barrier for the drug molecule is the cell membrane. So the molecule should cross somehow the cell membrane. Am I right?
Yes, sir.
Yes, sir.
Okay, good. So, for crossing the cell membrane, the drug molecule should have some property. Otherwise, the molecule cannot cross. It cannot penetrate. It cannot enter into the cell. The first condition is the molecule should be in its neutral form. If the molecule is in its charged form, then the molecule cannot enter into the cell. Okay, so I just make a simple illustration here for your understanding. So I have two molecules here. Okay, so one is the red color molecule, another one is the black color molecule. So this black color molecule is in its charged form. So which of these two molecule can enter into the cell? 1 and 2. Which of these two molecule can enter into the cell? Just now I told the criteria for the molecule to enter into the cell.
One, sir.
The molecule 1 can enter into the cell, the molecule 2 cannot enter into the cell. Okay, the reason is that the molecule 2 is charged, it is present in its ionized form, so the molecule cannot enter into the cell through simple diffusion process. Is it understandable?
Yes, sir.
Yes, sir.
Yes, right. So I am going to introduce another term now. All these are interrelated to the problem that we have solved. Say there is a important process called as absorption. I think already I defined what is meant by absorption to you. Do you remember? The journey of drug molecule. In one of the lecture I discussed, extensively about the 4 important major pharmacokinetic properties. So can you tell what is meant by absorption?
So the process by which the drug molecule enters into the circulation from the side
Okay.
of administration.
Yeah, enough. So the process by which the drug molecule enter into the circulation. Okay, from the site of administration, right? So if this is the definition for absorption, can you tell whether aspirin will be absorbed more in stomach or intestine? You have to relate all the concepts what we have discussed so far. So my question is whether this aspirin molecule will be absorbed more in stomach or intestine.
Sir, it can easily be absorbed in the stomach, I guess, because it's more in its unionized form in the stomach.
Absolutely right, because more number of molecules will be in its unionized form in stomach, because the pH at stomach favors the aspirin to present in its unionized form, but the pH at intestine, it is not favoring the aspirin to be present in its unionized form. So hence we can state that more and more number of aspirin molecule will be get absorbed near the stomach, not through intestine. Is it understandable?
Yes, sir.
Yes, right. So in terms of solubility, okay, so we already discussed about how the functional group favors the solubility of the molecule. So can we expect this aspirin to get soluble in water or not, based on whatever calculation we have did? Can we expect this molecule to get soluble in water or not?
Sir, not so quite easily.
How? So what interaction is, what is the relationship between ionization and solubility? Hmm?
Sir, if a molecule is needed to
What is
be
the
soluble in water, there is
between ionization?
there needs to be presence of the dipole-dipole bonding, or like the example of hydrogen bonding. If there is water solubility needs to be present.
It favor in, yeah, y- yeah. My point is, if the molecule in it, again I repeat, if the molecule is in its ionized form, will it favor the hydrogen bonding or not? Dipole dipole. Am I audible?
Yes, sir.
Yeah, any answer? Anybody have any answer? Hmm?
Sir, after metabolism, it will be water soluble.
Okay, we go with. Okay. If it is confusing, just leave it, right? So we go for one more problem. It's the last problem for ionization. Let me share my screen. So is my screen visible?
No, sir.
Yeah, now check it.
Yes, sir.
Is it
Yes,
visible?
sir.
So we go for one more problem, just note it down, right? So this is, I think, the third problem, right? So third problem, just note it down. So calculate the degree of ionization of codeine whose pKa value is 8.2 in a solution with pH of 2. Predict how the degree of ionization could affect the ease of absorption of codeine in the stomach and intestine. That is the concept which I discussed now. When the pH of stomach fluid is 2.0 and the pH of the intestine fluid is 6. This time the pH of the stomach is given as 2. Okay, the molecule is codeine. So what you have to do is very simple. You draw the structure of codeine first. You can use Marvin sketch or you go to Google first to draw the structure of codeine. So once if you have drawn the structure of codeine, the pKa of the codeine is given as 8.2. You have to look into the structure. You have to look into the various functional groups which are present, and you have to identify which of the functional group may have the pKa value approximately 8.2. Then using the given pH value 2.0 and 6, you have to calculate the degree of ionization, and you have to tell me that how that degree of ionization is going to affect the absorption of the codeine drug. Is the question clear?
Yes, sir.
Yes, right. So can you quickly do that? So can you take it as a homework?
Yes, sir.
Okay, so before coming for next class, right? So before coming for the next class, you just work it out, and you take photo of that and copy that to your one notebook, class notebook. Okay.
Okay, sir.
Okay, sir.
So I'm looking for answer from each and every one, right? Not only from 2 students, from all, right? So we'll discuss the answer for this problem, and we'll go for a few more problems related to this in the next class. Okay.
Yes, sir. Yes, sir.
Yeah. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.